In this video, I want to show you how to do a proportion interval, and that's confidence interval, and how to estimate the population proportion. I'm taking data out of the outline for Chapter 7 on page 7, and this shows the margin of victory on all of the Major League Baseball games played in 2016. I believe this was the regular season games. If you notice, most games were won by one run. Very few games were won by more than 15. So what I need to do here is I need to look at the calculator, and what we're going to do with the calculator is we're going to use this data here to come up with a 90% confidence level. We go to stat, and it's a test, and it's quite a ways down. I think it's down to the letter A, so it's after 9, 0, and A. It's a one proportion Z interval, and what we enter in here, X is the number of successes. What we're looking for is one-run games, so the 1372 will be the number of successes. So I put in 1372. N is the number of attempts. The number of attempts was the total number of games, which was 4,854. 4,854. And I want a 90% confidence level, a 0.9. And so then I hit calculate, and I come up with this result. This number, and there's a comma there, it's 0.272 comma 0.293. Those are the numbers, those are the critical values that show what's inside the 90%. And this 0.282 is actually the middle number. So we can take a look at that real quickly. The 90% confidence level is between these 2 points here, the 0.272 and the 0.293. And again, we don't have to go to z-scores, it calculates them for us. And what this interval tells us is that we're 90% confident that the true proportion of Major League games won by one run is in this interval. And what we mean by Major League games is all of the games in the 100 or so years that Major League Baseball has existed. We use 2016 as the sample. So this gives us a confidence interval. But we want to know what is the estimate of the proportion for the population, and that's really the middle, that's the numbers in the middle there. And the point estimate, we add those two numbers together, the 0.272 and the 0.293, we divide by 2 and we get 0.283, which that 0.283 was really the number we got here from the calculator. So this is how to find a confidence interval for a proportional problem, and then what the point estimate is. This is our best estimate of the population results.